Hey guys, just a quick example of how to do this particular problem on MyOpenMath. So this is in the video assignment. So we're trying to solve this inequality. So the first thing we need to do is figure out what are the zeros of this function. So we're just going to take the two parts of the factored part and figure out the um, roots here. So we have like x minus 4 is equal to 0, and then we have that x minus 7 is equal to 0. So that gives us x is equal to 4 and 7. So whenever we make our number line to test around, this is where we want to test around. So when I put my number line in here, I'm going to put in 4 right here and then 7 right here. So since I have two zeros, that means I'm going to have 3 test values. So I just need to pick anything that's over here left of 4, so I could pick something like 3, anything between 4 and 7, so let's just pick 5, and then anything above 7, so I'm going to pick 8 for my test value here. And when we test these, we basically just want to see if when I put in 3 into this, do I get something that's true or something that's not true. So if I put in 3, I'm going to get 3 minus 4 times 3 minus 7. And then the question is this greater than or equal to 0, question mark. And you can actually do this without actually figuring out the number. You know that 3 minus 4 is negative, and then 3 minus 7 is also negative. So a negative times a negative will be positive. So you know that this will be greater than or equal to 0. Of course, you could just go figure out that it's also going to be positive 4, but you don't actually need the number. You just need to know if it's positive or negative. So the same thing here with 5. If you put in 5 right here, 5 minus 4 is a positive number. It's positive 1. And then when you do 5 minus 7, that's going to be negative 2. So is that greater than or equal to 0? No, you're going to get a negative number in this case. So that's not true. And again, you could do that without actually finding the number. And then the last one we want to check is 8. So 8 minus 4, that's going to be positive. And then 8 minus 7, that's also going to be positive. So we'll end up with 4 times 1, which is positive. So that is greater than or equal to 0. So that is okay. So that means that this section here, maybe I should shade it right here, this section is part of our solution, and then this section is part of our solution. And then also 4 and 7 are part of the solution, because if you put in 4, you'll get 0. And if you put in 7 to this, you'll get 0. And 0 is greater than or equal to 0. So you have to really pay attention to the sign. So that tells us if we need to include these numbers or not include these numbers. So I'm just going to go over here and put in what I tested. I tested a 3, a 5, and an 8. And then down here, I just want to put, did I get a true statement or a false statement? So I got true for this one, false for this one, and true for this one. And now I just need to draw in what I got over here. So from 4 back to negative infinity, and then from 7 to infinity. Since it was included, I'm going to use the closed circle. If it had been strictly greater than, I would have used the open circle right here. And then we're writing these not in interval notation, but we're writing them in compound inequality notation. So go over here to inequality. So it's going to be all the x's that are less than or equal to 4, or all of the x's that are greater than or equal to 7. And that should be okay. Yep, there we go. So just in case it's unclear how you're supposed to put your answers in here, I hope that is a useful demonstration.